Okay, welcome back everyone and welcome to today's class. Today we're going to talk about transparent firewalls. That is firewalls that only operate on layer 2 with Ethernet, and basically it's like a network switch. Let's take a look at this network. So we have a PC1 and a unmanaged switch as well as a server. We have inserted a firewall between the switch and the server before the server was directly connected to the switch. This network is connected to a router which is connected to internet. A quite basic network. And we want this server to be secure, and that's why we have installed this firewall. So it's a clean firewall. Let's just do Cisco. We need to find a password that this one accepts. There we go. Okay, so this is a clean firewall. I will just set the host name to firewall1. And if we do sh firewall, then we can see it's either a router, which we were talking about in the last lecture, or it can be transparent. So the first thing we want to do is change the operational mode to transparent. And we do firewall transparent. Like this. We save and we reload the firewall. And while this reloads, let's see if the network is properly set up. If we go into this PC1 and we try to ping our next hop router, that's 192.168.10.1, like this. And we got a response. So this network is currently functioning. What we want to do is we want to set up a bridge group, because you don't configure IP addresses directly on these interfaces on the firewall, since this is not operating on layer 3 anymore. So basically we create a bridge group. Then we can set an IP address for management purposes only, and we assign that bridge group to these ports. Then we can configure security zones like usual. We just skip the step with the IP address. And we will be able to configure NOT rules. We will be able to configure access control lists and almost every feature of the firewall except for the layer 3 functionality. Okay, and as you can see, this has turned back to the default host name, because when we change mode from routed to transparent or the other way around, we lose the entire configuration. So don't do this unless you are connected through a serial cable, because you will lose the connection. Okay, let's log into this one and change the host name again to firewall1, like this. Okay, so if we do an shint IP brief to check the interfaces, we see that we have 4 different Ethernet links that we can use in order to forward traffic. So let's begin by configuring them to the bridge group. So So I'll go into the first Ethernet interface with the int command in front, and I will check its current configuration. It's clean. So I will assign this to bridge group number 1, like this. And let's do the same for the second port. No. Let's remove this. As we can see, we use port 2 and 3. So these are the ones we want. Let's go into port number 2 and add the bridge group. And let's go to the number 3 and add the bridge group. I will also add an IP address. And as I said, the IP address has nothing to do with forwarding traffic. It's just an address that is used in order to log into the firewall on the internet, and also as a source IP for several processes, like when you send your logs to a remote syslog server and stuff like that. So I will do int BVI1, that's a bridge virtual interface. So every bridge group has one. And I will set an IP address on this 192.168.10 network. And I want to use the last one in the network. Sorry, I forgot the address command, like this. Okay. We will also need to set up routing so we can connect to a syslog server or be reachable through the internet. So, but before we do that, we need to set up the security zones. So usually we define the security zones with the IP address and everything, but this time we'll do it without. So this server will be on the inside, and this rest of the local network as well as the internet will be on the firewall's outside interface. So the port number 2, that's the outside interface. I will give this the name IF of outside, security level 0, and that's it. Then we go into, and we'll do no shot as well. Then we go into port number 3, that's our inside interface, and I will do name EF inside and security level 100. So our configuration on the ports looks like this. Oh, I once again forgot to do the no shot. But the configuration looks like this: bridge group, name EF, security level. Bridge group, name EF, security level. So let's do no shot and save. Okay, so now this server 1 should be able to connect to the outside. But I will also turn on inspection for ICMP if that's not already configured. Let's see if it is. It shouldn't be, I think. Nope. So let's just copy these 2 lines for the default policy map. And I will enable ICMP inspection so we can send pings and test the network. I will also create a route, and we will use the outside interface, and we'll use this router as our first hop. And that'll be 192.168.10.1. Okay, let's see if we can ping our router. Yes, we can. And if we have configured this correctly, server 1 should be able to ping the router as well. And it can. And if we go into the firewall and do a couple of show connection, we got it right the first time. We can see that the ICMP echo request is in the connection table. Okay, so that works. What about connections from PC1 to server 1? Since PC1 is on the outside level 0 interface, it should not be able to ping the server with the current configuration. Let's see if that's true. So 192.168.10.201. Nope, it doesn't get through the firewall. But what if we want this server to be accessible? Then we can create an access control list just like we usually do. So we can do something like access list, let's call it server 1, and it'll be an extended list, and we want to permit ICMP. Let's just do that to begin with. From any to 192.168.10.201. Did I miss one step? External permit. Source IP address any. Destination IP address 192.168.10.201. Netmask. Okay, let's do this instead. Host. There we go. So if we do sh run access list, we have this one, and we will apply that access group server 1, and we'll enable it on the in direction on the interface outside, like this. So now PC1 should be able to ping the server, and it can. Okay, so it works basically like in a routed mode, but there are some features that are specific to the transparent firewall, and that is layer 2 access list. For example, we can permit or deny stuff like BPD use for the spanning tree, or some ISIS packets, the routing protocol. Usually a protocol like that, like ISIS, does not get through the firewall at all, and it's not possible to enable that. But when using a transparent firewall, it is possible. So let's create a new access list, and let's call that layer 2, and it will be an ether type access list. That's basically the layer 2 one, because what it's able to check for, it can't check for IP addresses and stuff on layer 3, but it can look in the Ethernet header and the Ethernet header's ether type field. So we can check for like if the protocol is IP, if the protocol is BPDU, etc. And I want to deny BPDU, so spanning tree won't be able to get through the firewall to this server 1. And that's basically two reasons. The reason one is you should never have spanning tree to a server. That's not really necessary. And if you configure it badly, it could end to result in loops. So it's good practice, and it's for security reasons that I want to disable that. Also, when we have spanning tree enabled on the switch, for example, we will have to wait for the server 1 to respond, and that might take a while. So in some cases, that's good to just filter them out completely. So let's deny BPDU, and here is a list of different protocols. We can also put in the numbered value for the protocol ourselves. So deny BPDU, and that's all there is. We can also permit ISIS, and if we were to end with deny any, sometimes you do that, even though that's usually a implicit deny any at the end anyway, but often it's good practice to include it. However, when using these ether type layer 2 access lists, you should never end with deny any, because these layer 2 access lists are being parsed before the layer 3 ones. So if we do deny any here, then everything will be filtered out, and it won't listen to even if we have a permit all on the layer 3 access list, it still won't get through. So don't do that. Let's see the access list we just created, layer 2. There we go. And we apply it the same way. So access group layer 2 in on interface out on interface inside. That's right. We don't want any in this direction. And usually we can't do several access groups on the same port. Okay, this isn't the same port. But if we were to put it on the same port, it would work, because you can have one layer 2 access list and one layer 3 access list on the same port in the same direction. And let's just check that we are still able to ping our first hop router. Yes. So everything is good and well this far. Another thing which is good to combine when increasing the security with a transparent firewall is that we perhaps don't want the server 1 to be a part of the ARP process. At least we don't want to flood with ARP requests, and we don't want server 1 to be able to determine its own IP to ARP, IP to MAC address connection for security reasons. And we can do that if we begin by checking the MAC address table, then we should be able to see the MAC address of server 1, I think. Outside. Yes, I think it's this one. Let's double check from this end. So if we do ifconfig on the first interface, let's see. It ends in 0319. Outside, or maybe that's not it. Do we advertise another address? What if we were to do it here? So, no, this is the right one. So let's create a static MAC address to server 1. So we can add a MAC address directly to the port with this command. So configure MAC address pool. No, that's not it. MAC address. Okay, let's begin with the ARP connection. And we'll do a static ARP entry for the outside. No, for the inside. I checked the wrong port before. Okay, so if we look at inside, here we are. Yeah, this is the right one. This is server 1. Okay, so let's begin by doing maclearn, and on the inside interface we want to disable the automatic MAC learning process. Instead we want to add a static MAC address MAC address table static. There we have it. And that's on the inside, and we put the MAC address there. So this is the layer 2 MAC address table. This is not the ARP table. So this automatically gets populated when the firewall sees a Ethernet frame from server 1 with this MAC address as source. And that's the process that we are disabling. So we will not be learning any MAC addresses dynamically. Instead, we have this statically defined one. And we'll do the same with a static ARP entry. We'll create an ARP entry for inside with server 1's IP address, and that's 192.168.10.201 with the MAC address of server 1. We will also enable ARP inspection. ARP inspection basically means that when an ARP request is being sent from this, when an ARP request is being sent from this server, Firewall 1 will control the contents of it. So we're not trying to spoof any ARP requests. And that will effectively disable any network sniffing if the server were to be hacked. And this is 2 on the inside. We'll enable it and we'll add the no flood keyword. And this basically means that if we get an ARP request, Firewall 1 won't be sending it to server 1. Okay, so now we have enabled ARP inspection. We have disabled automatic MAC learning. Instead, we have inserted a static ARP binding. We can check that by show MAC address table. Here it is. It's static. And if we do show ARP, same here. On the inside, this is tied. And you can see that it's statically tied by this dash here instead of the timer. We have also created a static MAC address for the MAC address table. So if we have done this correctly, server 1 would still be able to ping our router. And it can. So it works. But if server 1 were to be hacked, then we have some protection, at least. Okay, the last thing we're going to go through is the NOT. So let's say server 1 wants to do network address translation directly with this layer 2 transparent firewall. So when server 1 sends an IP packet to the internet, the firewall, even before it reaches this router, the firewall will change that 192.168 address to a 193.234.88 address. And then it goes to the internet, and then we'll make it go back. That can be achieved on a transparent firewall. We don't need any layer 3 for that. Well, this is kind of a layer 3 feature, but you know what I mean. Alright, how do we do this? Let's start by defining the 2 addresses that we want to translate. And we will do a static NOT. So we'll start by creating a network object network, and we'll call this object server 1. And this will be its entire IP address, 201, like this. We'll also create one for the outside IP, and we can call this xlate. And the router is using the .1 on this network as well. So let's say we use 193.234.88.2. Okay, we have the objects defined. Now we will just do the translation. So as usual, if you don't know a lot of these NOT configurations, I will do a more in-depth lesson about NOT, probably several lectures about NOT later on. But for now I will just show one easy configuration, so in order to demonstrate that it's still possible even though transparent firewall. Okay, so I'll go back into the first local object. Then I want to do NOT, and we'll go from inside to outside. It'll be a static entry, and we're gonna map it to O xlate. That's the object we defined before. Like this. Let's save. And if we do sh not, we can see that we translate from inside to outside, from the O server, this IP address, to the O xlate. This is the 193.1. And we don't have the rest of the network set up really, but perhaps we could do some debugging here. If we do debug IP packet and we let the server ping the router 1, just one ping. Okay, it did several. Let's see. We got a... Oh, that's not it. What IP address did I ping? 192.168.10.1. Let's try something. If we go to the firewall and we do the same, we ping 192.168.10.1. It doesn't show. Okay, we need to... Oh, here it comes. Source 00. Nope. Maybe we need to do debug. What did I do? SH debug. IP packet. It still doesn't really show. Maybe I need to edit the logging. So logging console 7. Debug IP. Debug IP. Packets. Detail, perhaps. Let's see. Let's see if it's here somewhere. IP source, that's DHCP, I think. What if we were to do debug IP ICMP? That could be the one. We are pinging the router, so it should get results. What if we were to do this? IP access list temp, and we'll do a standard 1 IP access list 1 IP access list standard 1300. Okay, it's a different syntax nowadays. IP access list standard 1. Then we do permit, let's say 192.168.10.0, and should this be a wildcard mask? Okay, 000255, and we'll do the same. We'll do the same with this one, 193.234.88.0, like this. No, that's not it. Let's remove this one and remove this one. We need to do the log as well. That's why I wanted this in the first place. So, 193.234.88.0 with log, because when you do an access list, it's usually handled by the ASICs. So it's not, you can't see it in the logs or anything or on the screen. But when you do the log, then every one of these packages will be bumped up to the general purpose CPU of the router, and then you can see in the debug messages and in the log files and so forth. So let's go into gig 3 and we do IP access group 1 in, like this. We'll remove all debugging. Let's see what happens if we do the ping this time. Okay, so it permitted from this IP address to this IP address. Great. So what if we were to do the same from here? Let's do 2 of these. Permitted ICMP from 193.234.88.2. Look at that. So we are able to change our IP address according to the NOT rules. However, the return packet doesn't get back to this server. And that's why when the return packet arrives on this port, it stays on this network, because this is that network. In order to be able to reach this one, because the NOT doesn't happen before here, so we need to create a static route for that exact IP address 234.88.2, and it'll be a /32, and we will route this to 192.168.10.201. So we will take a real public IP address and route it to a private IP address. And usually, in most cases, you should never ever do this, because you will destroy the end-to-end reachability. Plus, it's considered bad practice. But this is an exception. When you are doing not on a transparent firewall on the inside of this network, then you can do this. So let's just do it like this, and let's double check. So we have a static entry like this. So if we go to this one and we ping the router again, we get our response back, even though we are using 193.234.88.2 as the source in the firewall. We can also do a show xlate here. If we were to prepare this and we do like this, and we go bam and bam. Okay, it's a little bit tricky to catch it because everything is happening so fast. Let's remove the -C2, and then we'll try again. One in use. I think we need to give a detail. Here we are. So we have not from inside and this inside address to outside this. And everything is working as intended. So what have we learned today? We have learned how to create a transparent firewall. We have learned how to create a layer 2 access list, and how to use standard layer 3 access lists and not through a transparent firewall. We have also learned how to filter and enable BPDU frames, and how to disable the automatic MAC learning process on a specific interface, and instead create a static layer 2 entry, as well as enabling ARP inspection and creating a static IP to MAC binding. Thanks for watching, and thanks for today.